Welcome to Café Weltschmerz. Today I'm talking with Emeritus Professor Beda Stadler from the University of Bern. He used to be the director of the Institute of Immunology of this university, and he has quite some things to say about this coronavirus pandemic. Thank you so much for joining me, Professor.
You're welcome.
You have worked for quite a long time at the University of Bern as an immunologist, or am I seeing this wrong? So may I ask you, what did you do?
I was heading the Institute of Immunology, and we were always a group of about 50 people, about half of them working in research, mainly research in allergy, vaccine production, artificial and natural antibodies. That's what, so basically, and autoimmune disease. So that's the field that we've worked in. In immunology, you would say, I worked basically with the B cells, and immunology has two most important cells. The B cell, that's the one that makes the antibodies, and the T cell, that's the one that can make immune suppression, that can recognize cancer, and so on, or viruses.
That's the hunter, right?
Yeah, it's the hunter, right?
It's the hunter, yeah. So I imagine for you, this is quite an interesting and busy time during this coronavirus pandemic. And I've read your article and listened to most of the podcast for how much I could, because my German it's okay, but not very good. I'm very, very interested in what you've got to say. And where I would like to start maybe is how related is this virus, in your opinion, to viruses that we already know, or at least that our immune systems are known to?
It's a virus, a coronavirus. And if you can say that before even you know what it's doing, that means it belongs to a family. And this family has several groups. And one group, the beta coronaviruses, there are a couple of them. Some have already made some troubles worldwide. That was SARS or MERS. But there are other coronaviruses which always go around the world. And people get mad if you say it's a virus that makes a cold. Basically, also SARS-CoV-2 is a virus that makes a cold. But yes, right now it makes for many people more than a cold, and it's creating some problems. But before we start, I mean, I started, in Switzerland, I'm known and I was kind of involved in this discussion, but I'm not eager to be in this discussion unless all of a sudden I felt immunity is not taken enough, is not given enough credit in this whole thing. And let me start with a small story.
Please.
In 1846, there was a Danish carpenter that went on land at the island of Faroe. And this Faroe Island, that belonged to Denmark, and it was a population of a little bit more than 7,000 people. He got at land, but he had the measles. But in this time, the measles were not known, and it was, the disease was kind of known, but it was of course not known whether it's a virus and all this. So no specifics. So he goes on land, and then within several weeks, 6,000 people got sick on this island of counting a little bit more than 7,000 people. And there was one doctor there, a Danish doctor, who observed all this. And then he realized some people didn't get sick. It was the old people. That was very strange because children were dying, middle ages, but the old people above in pension, gruftis like me, they were surviving. And then these people said, oh, we remember this kind of disease we had as young children. So those were survivors from a measles epidemic on this island. And then it disappeared for 60 years. Now the virus came back and created all these problems. And now they were immune. So and then this was for an immunologist. This is a story that everybody has to read and learn because it was so typical. Nowadays, it's just the opposite. Now we have a virus that goes wild all over the world, but doesn't affect children. Children below 10 years are basically never affected. So normally everybody would say, okay, probably they are immune. But nobody said this. So that's what made me actually mad. People were repeating, this virus is so dangerous because it comes onto populations with no immunity, and the virus is new. And you started the first question with this: is the virus new? No, it belongs to a family. It has common peptides and proteins on the surface, but also inside the virus, which most of the coronavirus have. So there is, he has relatives, and the relatives have common structures.
So would you say that because a lot of people in the beginning, or a lot of epidemiologists would say, oh, look at our models, we have made models, the virus is new, so everybody is susceptible. But you just told me that at least children are not very susceptible or totally not susceptible. But I think this might also hold for older people or even very elderly people who have had a different coronavirus. Is this true, or am I looking at this in the wrong way?
Yes, so the longer the more it becomes clear, the virus looks for immunocompromised people. And of course, during puberty, your immune system is the best, the highest. From then on, it goes only downwards. Your immune system becomes worse and worse and worse. And the older you get, the more troubles you have, autoimmunity, cancer, all these things are because your immune system is no more working as it should. But some older people still have a perfect immunity. So it was not possible to infect them. And right now, the tragedy goes on. Like most people don't realize, America, who has a real problem now with the virus,
Mhm.
five the five biggest centers of the disease outbreak are prisons, jails.
Mhm.
So, so the virus looks for immunocompromised people and people who are cannot avoid other people. So in America, people don't like to talk about this, but it's their social system which is a problem.
Mm.
And in Europe, we don't have this problem. We don't put so many people in jail, and we don't have jails and situations like in America. And we don't have all these racial problems that America has. And now the virus goes around the world. It doesn't look for the same risk patients as with us. With us, it's predisposed with disease and elderly. But in other, like in Brazil, you don't have these elderly people. They died from other reasons. So it's young people there. But you have the poor, you have the malnourished, you have the people who starve.
Mhm.
If you live in the favelas and you say, oh, just stay home, they laugh at you. They have to go out,
And
else
there's no
they
other
don't
way.
have anything to eat.
Uh-huh.
So, so and now the virus looks for exactly these places.
So are these immunocompromised people not also very susceptible to other cold-like viruses, like or influenza or other infectious diseases?
Yes, of
Or is
course.
this virus especially dangerous, would you say?
It is especially, nah, not really especially dangerous. It's one of the risk factors for people with such predispositions. The the same people also usually are can die because of influenza, for example. Influenza has a very similar pattern, with the big exception, and that's why you should not say this virus is less dangerous than influenza. But what you can say is this virus, the coronavirus, does not attack babies, it does not attack young children, and it does not attack pregnant women. And all three things are done by the normal influenza viruses.
Mm-hmm.
So if you ask me, what I prefer is right now, this virus is a danger for me, for people like me who are elderly and risk. But for all the other people, the virus is not dangerous. It's a serious cold, but it's not dangerous. So
But how come we got so scared of it? How come our politicians took this as a warrant to lock down everything and everyone?
yeah, the problem of us humans are that we have still brains that resemble the monkey brain very strongly. I was scared to death as well for 2 3 weeks, and I couldn't think clearly anymore. Everybody was. We
Mhm.
were fed with videos from Italy, where probably many people died because they were maltreated. Doctors didn't know yet how to treat these patients. They treated them wrongly, or they made the situation worse. It is known now that they get people from infected people from the emergency room were sent back to asylums for the elderly. The most stupid thing you can do has been done. And yeah, and
But
we saw these pictures, and these pictures created panic. And there, for example, in Switzerland, I got so mad, and I'm still mad if I think that some of my colleagues, some medical doctors, went in public and said, "By the way, probably we have to make a triage. The people about over 80 will not get ventilated. They will not get." Even very young people heard this. This created such a mass panic that everybody said, "Oh, this must be dangerous." If you already by now, and then at the same thing, and that's something we have to talk really about as all the societies. I don't know how it was in Holland, but in Switzerland, people said we have to make a decision between protecting the system or the patient. And I had such troubles with this decision. And finally, everybody tried to convince, and I also started to believe it at the beginning, that maybe we have to protect the system so that the collateral damages are not too great and not too many. But then within 1 to 2 weeks, everybody could find out that maximally 6% of the emergency beds that were created or proposed were ever occupied. So the system was never in jeopardy, never. So
no,
that is a big problem now. And for this, I would expect some excuses. That really created a panic.
yeah,
And then it,
honestly,
it took a couple of weeks until people started to think.
the mainstream media is definitely a culprit in this. I would believe. I hope if you would give me your opinion on this, but they seem to have made the panic worsened by orders of magnitude.
Yeah, and the problem is that there were always some reasonable people that came up, like Professor Bhakti in Germany,
Mhm.
who had a wonderful record in his work, but because he was such in opposition to the mainstream media and all the experts that were talking to the government, that there's a new system that came up that everybody who was not in line was immediately put into a corner of wearing aluminium hats, and
I know. Yeah, we
it
know. We are
is
in that corner.
that's very so. And also science, it's a good thing that there were so many different opinions in science, and but laymen don't understand this, because most systems that base on belief, there you have an absolute truth.
Yes.
In science, you don't have truth. You have different science facts, and then you have to find out who is wrong. And
Mhm.
scientists should be very happy that somebody was wrong, because
Yes.
you can learn from the faults. You
I
can
agree,
learn
but
from
this is not modern science anymore. In my opinion, modern science, one of the telltale signs is that it's 97% certain, and the issue is settled, and we should only continue, and nobody's allowed to talk against it, and mainstream media controls it.
yeah,
I'm
that's a big problem, and this development is dangerous, and we have to talk about this
yes.
and change it. Because it was not a bad thing that people learned that scientists fight together,
Mhm.
but usually we fight to find the truth and not to blame that one is is a denier. At the end, if you were not of the same opinion, then you were a denier, like
Yes.
a climate denier, and so on.
Yeah.
So just for fun, I was starting to call all my my scientific friends as immunology deniers, because I would just wanted to provoke them so that they would start thinking a little bit. And
You use it in your advantage. Such attacks.
yeah,
But please let's continue and go back to the coronavirus. So one of the major claims made was that asymptomatic people who didn't have many of the symptoms of coronavirus or none, they were still very infectious or possibly infectious. But this is kind of a weird statement, would you say? Or
yeah, that frightened me, because of course there are a number of disease where you have silent carriers for a small time, but here it was totally exaggerated. And and now we have to talk about the corona test, the test assay that was used. Because
yes.
if you are immune and the virus attacks you, you inhale it and you become infected. But if you are immune, you fight the virus and you destroy the virus. But the virus, in some cells, it can replicate. You still make some virus, but you fight it, and finally you win. So over a period of several days, you can be positive, because the coronavirus test, it measures only a very tiny, tiny piece of the genome of the virus. And if your immune cells have killed the virus, then you have debris, you have rotten
Remnants.
pieces of
Yeah.
the nucleic acids in your blood and everywhere, and the assay can pick up these rotten pieces, and then it looks like as if you're infected. You're not. You have won the fight. You're
Mhm.
immune, so it cannot discriminate. And then the second point is, if you say somebody without symptoms can infect, that means this person must throw a whole bunch of viruses out when he speaks.
Mhm.
In his droplets, there must be a load, a viral load, must be significant, else you cannot. But how do you make these viruses? These viruses are made by your body cells that have been destroyed. Then the virus comes out. Now, if you do this, the, the body will immediately recognize this and say, that's and will immunologically react against it. And that's called an inflammation. And if you have inflamed regions, there are 5 cardinal symptoms, but one, it's not only that you get fever and all this. No, it's pain.
Mhm.
So if somebody says, I have not felt anything, no scratch, nothing, no symptoms, but I have that is a ridiculous assumption. Imagine, I could walk around and say, oh, I had AIDS for 2 weeks, but I didn't have symptoms, and now I'm fine again. Who would ever, you know, if you can all of a sudden have a viral diseases without symptoms and transmit the disease constantly, this is for our health system a huge problem, because any school pupil who doesn't want to go to school, he can tell the teacher, look, I
makes
had
sense.
influenza for 3 weeks, no symptoms, but I had influenza. So I had to stay home because I would, so it's a ridiculous assumption. And I'm just amazed how everybody is repeating it.
Mhm.
And I was going to the virologist who published this first. Let's not mention the name, but this guy at the crucial moment where where the proof should come that the viral load is not just a PCR signal, but true infectious viruses.
Yes.
At this moment, he cites another paper and he says it has been proven that, and then comes the
Oh,
citation. And in
beautiful.
the citation, he cites himself, an old paper, So when I saw this, I was shocked and I said, Jesus, no, not Jesus, but
Some other.
how can you do this? This is
Yeah,
so we had
quite
lots of
scandalous.
scientists who just wanted to be the first. They didn't
Uh,
care what they publish. They wanted to be the most beautiful, the first, and also impress anybody and get support from the government.
and it was added into the maelstrom of fear that the
Yeah.
media was creating, and bomb, it went out. But you're saying that basically everybody who is infectious must have some kind of dying cells in their lungs or wherever, and these hurt. You can't just be very infectious and not have any pain or inflammation.
I mean, it's very rare disease where you don't feel anything. If you have a disease where you don't feel anything, then how can you ever find out that you had the disease? But if you have a too sensitive test method, the PCR for coronaviruses is okay if you want to see where are some residues, where is it, and so on. There's nothing wrong with this test, but you can apply it wrongly. And you
Mhm.
can measure a piece of DNA and claim it was a viable, vital infectious virus. That it wasn't. It was just a piece of
Yeah,
RNA that you
yeah,
measured,
dead virus,
right?
long dead
Yeah.
remnants still test positive. But even in the case of like in Korea, where people were tested twice, and the second time, people would even come to conclude, look, these people, you can get ill twice, and there is no, some people don't build immunity and such. These crazy conclusions have come to
That,
us.
that's fun, and that's what I respect the Koreans, because this went around the globe, and even WHO took it up on their webpage to say that immunity is very bad and so on. And then about a couple of weeks, I don't know how many weeks later, Korea officially apologized for this, because they said they made a mistake, that it is true that they could measure the virus again, but the people had been immune in the meantime. And what they measured was just trash from the virus.
But
And
wait,
they
wait,
apologized for
this
this.
is very interesting, because when the news came out, a lot of people that totally have nothing to do with virology, just people on the streets, were talking about, oh, this is another one of those viruses, you cannot get immune to, it's so dangerous.
Right?
But I've never heard anyone talk about, or I didn't even know that the Korean scientists, they said sorry for this accident. How that's just too strange for me. The media should be as open with negative news as with positive news, shouldn't it?
Yeah, I have certain degree of understanding. It is for most journals, print media or video media. Most of them got rid of the science department that they once had.
Mm.
So now usually there is some poor journalist who is put on the track of some news story. He doesn't understand anything of this, and he has to make a story. And then he goes and calls three experts, and then he gets mixed up from all what he heard, and he does. So I have some degree of understanding, and the problem is that yeah, there are basically only some very big, very large print media who still have scientists in,
Mhm.
in their redactions, and that's one of the problems. So that's why this time scientists were also so much in need, because the journalists wanted somebody to explain it, but when I was young, the problem was in the public. If you had money from industry to do your research,
Yes.
then you were not believable. You're not trusted. Now it's all of a sudden the opposite. The industry doesn't support so much anymore, and scientists are extremely dependent on the governments.
Yes.
So, and this has created the same situation. Now we have all these experts who give the politicians exactly the opinions and what they want to hear so that they can get the support from the government.
Yes.
In Switzerland, I know some guys who, for example, at the time when we had the BSE story, he went on TV and said, Switzerland, you has to count with about 10,000 deaths because of BSE, of
The prion disease.
the prion disease. And everybody was shocked. He got several millions from different foundations for his own research because of this, because he was the expert and he claimed that he can do this and he can prevent certain things. Not a single person ever died in Switzerland because of the prion disease, And the very same person this time came immediately up again and said, Switzerland has to calculate with 60,000 tests.
This is the weird thing to me.
We had one like this. I'm sure that they.
It's the same in the Netherlands, and it's the same in most European countries. It's the same offenders that make the wrong models that don't work, that scare people to death. They come again and again and again, and somehow they have some kind of authority to, to advise the governments.
Yeah.
Please, if you would, could we talk about the immunology test? How many people were immune before coronavirus? Because a lot of tests have been done and we don't hear so much about this. And many of the claims that people were immune to this virus, they were ridiculed, also here in this country, the Netherlands. What is your view on this?
Yeah, the problem is first that everybody said there is no immunity, but there was no test. There were no tests all over the world. So everybody said there is no immunity, but nobody had antibody tests. And then the first test who came out, the first one which came out on the market in Germany, was an antibody that formerly, previously was made against SARS. And because SARS is related to SARS-CoV-2, this antibody also recognized this new virus, the new, which has the same structure as the old one. And because SARS died out, there were antibodies around and people gave up to make a vaccine because even if you had one, you could test it and so on. So there was old material around that all of a sudden could be used to. That's the first point. Then I was asked by some venture capitalists, they sent me some information from Chinese companies who were trying to sell antibody tests in Switzerland. So I got all the information about the test and I called them back and said, forget it, this is just plain bullshit. It's always positive and measures everything. At the time, I didn't think much about it, but now looking back, it's clear that they just measured with the virus the natural, normal, residual immunity that's in everybody around, in you and me, everybody has this. That's why these tests were positive. And now, then there came several companies, and in between, what happens is that CDC starts to retract some of these antibody tests right now because they realized they are not precise enough and so on. So nobody has the repertoire of tests that you needed. You would need a test that could specifically see SARS-CoV-2. But then you would need a test that can discriminate between SARS-CoV-2 and other coronaviruses. And then you need a test who can measure, is it a primary immune response or a secondary immune response? You can usually do this at the beginning we make IgM antibodies, later we make IgG, and then the most important export antibody is IgA that we put in our mucous membranes, which would be the most important to fight the virus at the beginning. And then amongst all this virus, you always would have to discriminate: is it a protective antibody, a neutralizing antibody, or is it an antibody that can collaborate with the normal basic immunity? For example, IgM antibodies can take in other proteins like complement.
Mm-hmm.
That's a very important group of proteins in our body that together with antibodies can fight also viruses.
Mm-hmm.
So there's a whole plethora of assays that you would need where you had to study the immune response of people who have been sick, who are sick, who never have seen the virus, and so on. And all these tests are not around. They're everywhere people are making now tests, but most of them just make tests against the spike protein
Yes,
of
it's the
coronavirus.
same in the Netherlands, and then they conclude that 3% of the people have had the virus, and so actually the situation is super bad, and there will be a second wave with the other 97%. And
right. So it's plain stupid. I mean, of course. I mean, of course, anti-spike antibodies are also important, but it's not the only one. You can have against other structures.
Yeah.
And people don't know how many structures actually can induce protective neutralizing antibodies. That's not known about this virus.
So you could, sorry to interrupt, you could be immune, let's say, without having specifically antibodies against the spike protein, but for example, against parts of the RNA or certain other components of the virus.
Right, not the RNA, but things, structures on the surface of the virus.
Okay.
The RNA is not so important. Once it's in the cells, or without the virus, the RNA cannot go into the cells.
Oh, I thought, excuse me, I thought that the RNA
was. And then there are other proteins which are common in all beta coronaviruses, which help the virus to replicate and so on. Mm-hmm. These only come about once the virus is within the cells.
Yes.
So, but everything that's on the surface, and there, if you have 2-3 proteins of this size can induce several hundreds of different types of antibodies against it. So, and among them, you can have several. Now, in addition, what comes is, in order to say that you have a neutralizing antibody, people use cell lines. And then they throw virus on it. The virus kills the cell line. If the antibody is there, cell line is not killed. Yeah, it's a test. Mm-hmm. But this virus infects so many different cell types. And to see whether normal cells are also protected, you could guess it a little bit from a cell line, but it's not a true test. Mm-hmm. So for some viruses, you had to do a challenge test in the animal, but you cannot do this because the receptor that the virus binds to, you would have to make an artificial animal first to prove this and so on. So in other words, there's so many open questions, but the most important point here to realize is everybody who claimed there is no immunity had no assay to prove this. So it was just a gut feeling and not science, you know.
But a gut feeling made by some very unprofessional virologist, or am I wrong? Because this
not only that, everybody claimed this. You know, everybody said the virus is new and there is no immunity. And I heard it from the best, most famous immunologists in America, in Switzerland, in Germany, everywhere. Everybody repeated this, but nobody had, while they're at the beginning when they were saying this, nobody of them had an assay to prove what they're saying.
Actually, but they were very wrong, weren't they?
Yeah, now the longer the more there are papers coming out showing that there is immunity, there are cross-reactive antibodies. Now, people have now even found in a llama, they have found an antibody that recognizes SARS-CoV-2 and MERS. So the longer the more, also the assays that people try to make create problems, because all these naturally occurring antibodies from previous cold infections are interfering, and they desperately all try to make a test that is not interfering with these antibodies, and thereby they miss probably the most important antibodies, and they run after a specificity which is probably even not so important.
Mm. Mm. So, what do you think of the use of models at the beginning of this crisis? All kinds of specialists, epidemiologists, they made a lot of models, and these models forecast huge amounts of deaths.
Yeah, I mean, these models are, maybe it's even exaggerated to call them models. The models are only as good as the assumptions you do.
Yes.
And first, they made the assumption the virus is new and there is no immunity. So the models are based that there is no herd immunity, and their models were based that herd immunity slowly builds up and so on. Their models also didn't realize that there are super spreaders, and most people do not spread dramatically. And the super spreaders, I don't understand it, and I don't know how much fiction and how much reality is in there. It's an interesting concept, but I think I have never heard an explanation why somebody would be a super spreader. What happens in such a human being that he spreads the disease different than others? It's another concept that has been proposed but not proven.
So the blood bank, one of the institutes here in the Netherlands, they had a very political headline above their study. The immunity study, which showed in the beginning it was 3, and then a few weeks later it was 5.5% of our population here in the Netherlands was immune. And they said herd immunity is not an option, basically something like that, or it was a very far-flung option. I find that very political and not very scientific. Would you agree? Because they only studied one, like I said, only the spike protein.
And there are several experts who claim that we need 60 to 70% herd immunity.
Mm-hmm.
Everybody who said that made this proposal based on, believing it. It was, we don't have data. We don't know how big the herd immunity must be. If they would now start the ground immunity that is there, this basic immunity, which is from cross reactions, then you probably would need a much lower herd immunity. There are experts who say if the ground immunity is elevated 20% or more, maybe you need only a 20% herd immunity to get rid of the virus. And what is known is wherever you had SARS, the first of these virus types, SARS-CoV-2 had almost no chance to infect people. That's another observation, that immunity plays a role. And then SARS disappeared. Usually a virus disappears if it cannot find anybody to infect,
Yeah.
So it runs dead. And at present, we don't know how big herd immunity really must be. Somebody has claimed 67, but I have not seen real science about it. And we don't know how great immunity is. What we know is from more papers now is that our second type of defense, not with antibodies. So far, we have primarily talked about antibodies. They are important at the beginning to guard, to shove the virus away, to kill it rapidly, to hinder entrance in the cells and all this. That's important. But that's not complete. In biology has no 100%. So you will always have some viruses that are successful, go in.
Mm-hmm.
And then you need the second arm, and these are the T cells. And the
Yes.
T cells, they are kind of stupid cells, but what they can do is whenever you have a cell that is infected or
Mm-hmm.
is changed with cancer or so, it shows on a little presenting protein, little tiny proteins,
On
peptides,
the outside. Yeah.
and then T cells can recognize this. So it's not very specific what they see. It's much less specificity than what an antibody sees.
Mm-hmm.
And now people have looked, there is a study, several studies now, for example, one in Berlin, where they looked at people who had never contact with SARS-CoV-2.
Mm-hmm.
And among those people, 34% had T cell immunity. 34%. So in other words, the natural immunity
Mm-hmm.
must be in that order. It's not that you have 34 T cell and no B cells or so. It's, there is not a dichotomy in the immune system. You always have both arms that develop together. So I would assume that the basic immunity is also in that range. You could just count all the children below 10 that are not infected and not, then you can, people say 90% of the people who are in contact with the virus have basically no symptoms. So if you count them all, then you might have a kind of a basic immunity between 40 and 60% already.
Yeah.
And that would then be the explanation why it disappeared everywhere in Europe.
Yes. And also because it was summer, right? I mean, most of the
And
time.
it was summer. That helped in addition, the UV light and so on.
Yeah.
And then, but people say, no, but look at other countries, it's different. Yes, the virus does not only go away because of the sun. And if you give this virus a chance to infect several times, and that's the point of America with all the jails, the 5 centers, these people live so close together that they don't infect each other once. They
Mm-hmm.
probably do it several times a day. And until you're immune in 2 weeks, during this time, if you constantly get infected,
Viral load adds up.
and there is now several examples in this direction. For example, the Navajo Indians in North America, they had they had these casinos, but not much work was there. So the casinos were closed. So all these Indians were without a job.
Mm-hmm.
But culturally, they liked to meet in big rooms and be together. So, in other words, the viral load that is provided during infection plays a role. That's why all the tracking apps that are now coming, they only make an alarm if you are 15 minutes together with something,
Okay.
So, like measles, it doesn't take 15 minutes. Something is really infectious, that you could go in a room where 2 hours before somebody with disease was in the room.
Uh-huh.
You go in there for 10 seconds, you go out. You can have measles when you go out.
Uh-huh.
That's infectious. So, and this virus needs a lot of time. So, in other words, a high
Moderating.
viral load, lots of droplets with viruses in it. And and that's why I always say, go out, go in the sun. But if you live somewhere like in the favelas, where people are close together, many people, malnutrition, you have no chance to evade. You have to be close to all the others. You will be constantly infected. At the end, your immunity breaks, you lose, and the virus can start fighting you now, and rather than you would fight the virus.
The health of the immune system is really important, I would say, because um, as you see, like the prisons, I don't expect people in prisons to have the best immune system, also in favelas or like elderly people. Um, this really plays a big role in this. Um, I think the situation we've got ourselves into with this whole coronavirus pandemic is rather serious, wouldn't you say? And um, I'm actually a little bit astounded. I don't know how to say it. It, um, it worries me that so few scientists up to this point, and I think more will come later, have gone up and stood up and said, listen, 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 this situation, we make so many claims we don't know, the lockdown, the consequences are super harsh, and it seems like a very difficult thing for scientists, especially those who are paid and have a job under a government or a university,
Yeah.
to come forward.
But there are two interesting things. First, when I wrote the article, that's now more than almost 2 weeks ago now, almost. I hope, or I expected some very harsh reactions from my colleagues. Very interestingly, until today, nobody has attacked me for this. Nobody has said this is wrong. Nobody has said this guy is stupid or this guy is wearing an aluminum hat or whatever, So, so I was expecting that they fight this.
Yeah,
But what I say is so obvious
yeah.
that, and I'm since 6 years in pension, so I did not have any interest in being adverse
You're
to
safe because
scientists.
you're
So,
pensioned.
it's just I couldn't stand this opinion. That's all.
Yes.
And the second point, and that's made me sad. I had several young immunologists calling me up and said they were so happy that I spoke up. I said, "Why? You know me." They said, "Yes, of course we know you, and you were always outspoken. But we believe we are also immunologists. We believe you're right, and we have seen the same thing, independent of me." So, in other words, some of them were my former students, even.
Mhm.
So I was proud to be a good teacher. So, but the point is, and then I made fun. I said, "So why don't you say something?" She said, "First of all, when they did among friends, even there, they went all of a sudden they were in opposition, and people were attacking them.
Mhm.
Second, they said we did not dare to go out in public with it because I want to have a career." They were
I mean,
afraid of
this is
talking about
corruption.
this.
This
And
is corruption of
that's,
science.
I'm in pension. There's nothing that can happen to me,
Yeah.
unless you attack me, then I'm even think I can even have some fun with it. So
But you also have a very high stature, honestly, because you were the director of the institute. You have
yeah.
been a professor for so long.
Mm. So the second point is the most important. It shows that obviously, and it goes together what we discussed with being a denier or not. All of a sudden, science should be free of opinions.
Mhm.
Opinions do not matter. I'm not interested in any opinion, but facts. And what we've talked about now is facts. It is a fact that nobody had a test. It is a fact that old antibodies recognize this new virus and so on. So we talked about things which are facts, and there you can fight, and then the facts will win at the end.
Yes.
But if young immunologists are afraid to come up with facts, that means that some people are obviously so much in power that independent of facts, they can harm young people, you know.
Yes, I agree.
That's not funny. That's not.
And I think there is also a third point to be made, and that is that the standard character of of a scientist maybe not a very political one. I don't know. When I was in university, most of the scientists that I would meet or learn something from, they weren't the type to come out and say, "This is what we should do. This is how we should have how we should work against this virus or whatever." They weren't really. They didn't have aspirations to be a politician, and I think maybe the type of scientist that wants power, that wants to be a politician, is not the type of scientist that we want to have that power. Or
Oh, I'm glad you say this. To me, this is a very important point, because I was also believing the other sayings that, okay, as a scientist, you give the fact, the politician makes the decisions, and so
Mhm,
on. Since many years, I didn't do this anymore. I was heavily involved in gene technology, promoting this. I was in Switzerland. People called me the vaccine pope, you know, because I always was and I was fighting homeopathy and
mhm,
alternative medicine. All these things, I'm very much known that I have a large panel of enemies, and they're all in the same esoteric field, and so every belief system I made fun of, and especially also religion. I
mhm,
always made fun out of these things.
mhm,
But
mhm.
now, if what you're saying is that now all of a sudden, if science also becomes a belief system, you know,
Mhm.
where it's no more doesn't matter what you know, it's only matters who do you know,
Exactly.
and
Yeah, that's a very scary thing you just said. And
that's very scary, and
sounds
that's
like
why also
something.
some people say it was bad when industry just supported us, and I had lots of industry money for doing research. But
Mhm.
it is also bad if the government supports you, you know, with the condition.
Yes.
And and in all these promotion in these agencies that support science, it, these people they all know each other, you know, and so it's kind of a mafiosi type of thing. I you give me this grant, so I will close my eyes with this paper and so on.
Corruption.
That's not so. And we have also started to publish too many papers. You know, for each little tiny thing, people write up
Yeah.
papers. You know,
Yeah. Science, modern science is definitely decrepit in many areas. But I think that's for another discussion. May I ask you one last question, Beda, Professor Beda? What do you think of the second wave? The media is already blowing big winds of second wave coming. Um, is there going to be a second wave? Should we be afraid of it? What do you think?
no, there will be no second wave. There was once a second wave with influenza, but there the second wave was even deadlier than the first one because it was a period where there were no antibiotics. The medicine was completely different and so on.
Yes.
This virus will come back most likely this winter, but
Mhm.
don't call it it's a cold virus. It comes back. But if we now start to learn that all we have to do is protect the group of risk patients, then there are no deaths. If we can protect them,
Mhm.
then the young people can do whatever they want. It, to have a little influenza like disease for a week for a young person. Come on,
Oh, part of
that's
life.
yeah, so we can look. So I don't think that our society is no more constructed. We will have second and third waves in every country that has hidden social problems that we don't talk about.
Mhm.
Germany has such a case now, where in this butchery system, where Belgium had this problem because they had people working under miserable conditions, close to. Whenever people are so close together, similar like in a prison, and working, and where we have really social problems, the virus will find these places. But
Mm.
that's not a second wave. These will be clusters that come up, and where the virus shows us where do we have racial and other social problems.
Mhm.
And of course, there may be countries where the whole country is a racial problem, you know. So there it may look like a second wave because yeah. And if you look, it's good that the Americans look to Europe, and every country they see, in every country the virus is down.
Yes.
Right now in Switzerland, the number of cases, as they call it, are smaller than the specificity of the corona test.
Yeah. False
You know,
positive.
if the corona test has 98% specificity. So that
Mhm.
means if you test 100 people, 2 are false. Huh? So, and right now, Switzerland tests almost more than 5,000 people every day, tests every day. So that means for 102, for 1,020, for 5,000, 100. So we should have 100 false positive cases every day, but we only have about 20 to 40 now, fluctuating since 2 weeks. So nobody even knows whether the virus is still there. You know,
Mhm.
you don't know whether it was a wrong
But
corona.
you don't even have a way to know whether it's there or not.
You would have to isolate the virus sequences or infect cells with it, you know.
Mhm.
And if you don't do this, you even don't know whether the virus is still around.
Mm.
Right now, I'm just for helping the people a little bit to say, if right now in Switzerland you run around with a mask,
Yes.
then you should probably better wear a helmet because the danger that something falls on your head is bigger than getting infected by coronavirus.
Maybe you
That's
should wear the
the
mask on your
situation.
head.
That's the situation right now. So I know it's
Situation.
not in every country the same thing, you know.
All right. Beda, thank you so much for this interview. I had an absolute pleasure talking to you. You told us so many interesting things. I hope everybody who has been listening to this, watching to this, also found it extremely interesting, like I did. Um, Professor, thank you so much for talking with me. People who have been listening, viewers, thank you so much for listening, and see you the next time.
You're
Cheers.
welcome. Bye bye.
Tschüss.
Cheers.